Okay, today's going to be an easy day because I'm just going to give you an intro to chemical reactions and what they mean when I write them. How do you write them? How do we know if a chemical reaction has taken place? And then we're going to take that and move into what's called balancing chemical reactions. So when you balance a chemical reaction, um, you have to play around a little bit with some numbers so that we have the same number of atoms of each type on both sides. But before we do that, first of all, chemical reaction. Yes, Sam. Okay. Can you? Sure, certainly. Go get your notebook. A chemical reaction, as the name implies, is when two things come together, like chemical A and chemical B, and they react and form a brand new substance, something that wasn't there before. So an example of something like this is I could take some nitrogen and react it with some hydrogen, and I come up with something called, well, you know the name of this, it's ammonia. Now, this is a very simplified version of the chemical reaction. It's not balanced, but let's not worry about that now. These are just two things coming together and forming something brand new. So what ends up happening, these things somehow collide with each other, bonds are broken, new bonds are formed, and we form a chemical compound. Not every time we mix two things, you may or may not have a reaction. Sometimes you don't have a reaction just because we mix two chemicals. I always like when students say, what happens if we just go back there and mix a bunch of random chemicals together? Well, maybe nothing will happen. Maybe something will happen. We don't know. But as we go along, we'll figure it out. So let's talk about some indicators of a chemical reaction. So how to know if and I abbreviate it as RXN, makes it shorter, reaction happens. I don't know. What are the indicators of a chemical reaction? Can you think of any that might tell you that a reaction's taken place? Mix two things and what do you think?
Heat being produced.
Heat being produced. Yep. Change. I'm gonna say change in temperature because if heat is produced, then the temperature is going to go up. If heat is absorbed by the what's called the surroundings, the temperature will go down. Good, Noah. Change in temperature, up or down.
Explosion.
That'll work. Say explosion. Yeah, yeah. You know, if I take 75% potassium nitrate, 15% sulfur, and 15% charcoal. I think those are the rough amounts. I grind them all up in a mortar and pestle, and I somehow put a spark to it. You've made gunpowder. So those probably aren't the right proportions. I don't want anyone making it. So anyway, but you could look it up online. How about something else? Solid or gas is formed. Great. Solid or gas is formed. Let me show you a little something. Let me put this on pause for a moment. And the fourth one would be a color change. If we put something in a solution, very often when we're taking an acid and reacting with the base, we know that an acid reacts with a base because it'll warm up. We have a neutralization reaction. But if we really want to know when I've had just the right amount of acid to react with the base so that it's neutral, you put something in there that'll change color at that point as a function of the pH of the solution. So those are indicators of chemical reactions. Now, when I write a chemical reaction, let's just say I've got two things reacting and they form two different things. A plus B gives C plus D. This is just generic. So what we do is we call, on this side, we call these the reactants, because those are the things that are reacting. And on this side, we call these the products, because the products are the things being produced. Now you might see little parentheses, oftentimes you see little parentheses by the chemical compounds. Now in those parentheses, it might say S for solid, it might say G for gas, it might say AQ, that means aqueous, it means it's a solution. So if you see little abbreviations here, well then you will see that they mean what state is the material in. So this could be aqueous, and we can have an aqueous, and this one might be a solid. That's kind of like the reaction we just did, that I demonstrated. One of the products was a solid. So I want to show you sort of a picture of what it means for chemicals to react, because if we just look at formulas on the board, hopefully we can name them. I didn't get a chance to look at the quizzes. I'll do that during my study hall today, or my prep. But anyway, if I have this reaction, let's go back for a second and look at the N2 plus H2 to give NH3. What this really means is I have a nitrogen molecule and I have a hydrogen molecule, and they're going to come in together to form this molecule here. And don't worry, you don't know how to draw the structures yet, so this, just take my word for it. This is how we're going to draw structures later on. So it means I have to have a certain amount of this bang into a certain amount of that to get a certain amount of that. But there's a problem in this chemical reaction here. And the problem is, if I count up the number of N's on this side, 1, 2, and the number of hydrogens, 1, 2, well, if I look over here, I've only got 1 nitrogen and I've got 3 hydrogens. So we don't have the right numbers of things to combine and to be formed. So this is unbalanced. So what we have to do is we have to go ahead and play around with putting coefficients in front of these substances, because we can't change the subscripts. That would change the nature of the chemical. So if we're going to balance this, well, let's think about things. If I want to balance the nitrogen, I have 2 on that side. I could just put a 2 on that side, and that would give me 2 nitrogens. So let's try that and see what happens. So I've got N, I have 2 of them. Okay. This will all be online. And this 2, it distributes over both of those, just like in algebra. So I'm going to have 2 nitrogens, and 2 times 3 hydrogens, or 6 hydrogens. So if I put a 2 there, let's draw the picture. So I have 2 nitrogens. Now I'm going to have 2 of these. So I have 2 nitrogens on both sides. Now let's take a look here. 1, 2, 3, 4, 5, 6 hydrogens. What can I put in front of here to multiply through and get 6? 3. So I'd have 2 of these coming together with 3 of those. They react, and they form 2 molecules of ammonia. So that's what's going on in a chemical reaction. All right. Why don't you get that down? Time for a haircut. Or a hair transplant. I can't decide which. Okay. the next thing we're going to talk about are types of chemical reactions. It makes our life a lot easier at this level in chemistry, or at any level in chemistry, if we sort of catalog chemical reactions under one of several types. Now, we're not going to examine all the types of chemical reactions because when you get into organic chemistry, they have many more classifications of chemical reactions. But for us, in 11th grade, we are only going to concern ourselves with a few of them. And these are not necessarily for organic chemistry, but more this inorganic chemistry. So the first one we see would be something called a combination reaction. Also called a synthesis reaction. Okay? Now, we already saw one. We just saw one as an example. Two things combine to form one thing. So we just saw one, N2 plus 3H2 to give 2NH3. Two things combine to form one thing. That's a combination. So you can immediately recognize one if you see something like this. The second type is just the opposite. It's called decomposition. And a decomposition reaction is one thing breaking up into several things. Sam mentioned an explosion a few moments ago. It's really a decomposition reaction. If you take something like nitroglycerin and you cause it to explode, it breaks up into different things. And a lot of gas, that's what causes the explosion. It expands very rapidly. So decomposition would be something like, if I took something like this ionic compound, calcium carbonate, and I heated it up, I would get calcium oxide plus CO2. So one thing breaks up into more than one thing. I'll go back up here, put number 3 up here. Number 3 is called double replacement. Double replacement. And double replacement is, you can think of it as they switch their partners. It's like, say we just use an example, like let's say Sam and Cameron went to the homecoming dance, right? And they sat at a table with Connor and Ashley. My example's leaving the room now. But let's say you guys go to the dance together and you sit at the same table and you decide I like Ashley better and Connor decides I like Cameron better, so you switch dates. That's a double replacement reaction. So the one I showed you up here, I took something called silver nitrate, and that was aqueous, and I reacted that with sodium chloride, aqueous, and something happened. They switched their partners. Silver went with chloride, sodium went with nitrate. So silver chloride was the stuff that turned into a solid. And the other one would have been sodium nitrate, but that stays in the solution. So you can see this used to be here, now it's here, and this used to be here, now it's there. They switched their partners. Okay, easy enough. And we're gonna learn when we get into this more. We're gonna learn why a solid forms and how we can predict the solid that forms, and that's kind of fun. Okay, so I think we're on number 4 now. Mm-hmm. All right. 4 is a single replacement single replacement reaction. If a double replacement was something that where they switch their partners, think of a single replacement reaction like this. I have a compound plus an element, and that's going to react and give me a different compound, different chemical compound, and a different element. Okay. Think of this in the kind of way like if you remember, maybe about 10 years. Well, you guys are young. 10 years ago, there were. I lived in Mahoopany, right, and there were a lot of couples in Mahoopany, and then a bunch of gas workers came in, okay, and went over to the married couple and kicked out the husband and hooked up with the wife, right? That's a single replacement, and the poor ex-husband had to just go down to the Dandy Mart and sit there. So that would be your single replacement. An example of something like that would be lithium plus aluminum chloride gives lithium chloride plus aluminum. Now, this is not balanced. Let's think about how to balance this for a second. I have a 3 there. Everything else is 1. So if I put a 3 there, I've got my 3 chlorides, but I'd have to put a 3 there to go ahead and balance that out. Element plus a compound gives a different compound plus a different element. Single replacement. Last two are pretty straightforward. Acid-base. Acid-base reaction is a type of double replacement where you have an acid like HCl, for example. That's hydrochloric acid, and that's aqueous. And we react that with sodium hydroxide, aqueous, which is a base. And if you don't know that sodium hydroxide is a base yet, or you don't remember, don't worry. We're going to spend a whole unit on acids and bases. So when I react that, again, it's a double replacement. H goes with the OH and forms HOH, or H2O, plus NaCl. And this is a liquid. This is aqueous. So this is the type of thing where if I had a big glass full of hydrochloric acid and I had a big glass full of sodium hydroxide, if I drank either one of them, I'd be in bad shape. But if they were equal concentration and equal volume, mix them together, I just have salt water. I could drink that without getting too much, except high blood pressure. So that's an easy one to look at too, if you just recognize acids and bases, which we're going to learn about. Now, finally, the last one is called combustion. I forget which one we're on, 5 or 6. 6, I think, right? Yeah. Combustion. Burning stuff. And these are compounds that contain carbon, hydrogen, and oxygen. Maybe not oxygen, maybe just carbons and hydrogens. And we're always going to react them with oxygen, and we're always going to get CO2 plus H2O. Always. So if you see anything like this, and I'll give you an example of a real one. So this is just, I'll kind of put that in quotes because there are many, many different compounds that contain carbon, hydrogen, and oxygen. The only trick is we have to balance them when we're writing them. So let's take something simple that we can combust, like propane. Everyone has propane tank, maybe by their grill or your furnace or something. The formula for propane is C3H8. And if you see it reacting with oxygen, and you go here and you say, okay, it's reacting with oxygen, I have carbon dioxide as a product, and water, then you immediately can identify that as a combustion reaction. And let's see, let's try to balance this. I'm trying to work in balancing as we go along here. I've got 3 carbons on that side and only 1 there. So if I put a 3 in front of the carbon, now the oxygens are balanced. Well, I've got 8 hydrogens there and only 2 there. So if I put a 4 there, now I have 4 hydrogens or 8 hydrogens and 8 hydrogens, because 4 times 2 is 8. Now let's count up the oxygens on this side. 3 times 2 is 6, plus 4, that's 10 oxygens. So I have to put a 5 right there. Yes, 5. 5 times 2 is 10. So that's basically it in a nutshell. What do we have, like 5 more minutes before class is over?
8:43.
It's Wednesday, yeah, 8:43. So we have a couple more minutes. Let me just give you a couple of examples, see if maybe you can follow along on balancing. And we're going to spend tomorrow practicing balancing. I've got this sheet of like 37 equations to balance, so we're going to get plenty of practice. So I'll pick a couple from the sheet. All right. I got this one, NH4, 3 PO4, ammonium phosphate, plus oh, hang on, I wrote that wrong. We got ammonium hydroxide plus H3PO4, and that on this side is going to give me NH4 phosphate, ammonium phosphate, plus water. Now, first things first, let's take a look at the chemical reaction and identify the type of chemical reaction it is. Well, I have a compound, two chemical compounds. I should write aqueous, and this is going to be aqueous, and this is going to be liquid. So when we reacted 2 things and we got a different compound plus water, what type of reaction was that? Not combustion. You're thinking of if that was CO2 plus H2O. Remember, if I took something like a hydroxide and an acid, this is a base and this is an acid, and of course then you would get a different salt and water. But maybe you didn't recognize this as that. But you could have thought, well, the NH4 used to be with OH. Now the NH4 is with a PO4. The OH used to be with the NH4. Now it's with the H over here, H2O, HOH if you want to write it that way. So you could have called this a double replacement reaction. Double replacement. But it's not balanced. Let's take a look at why it's not balanced. Now again, I gave you that chart of your polyatomic ions, so you're always going to need that because the polyatomic ions stay together like a... Let's just call it a day because we're going to get disturbed with things and class is almost over. So we'll pick up on that tomorrow.